Click the bell icon to get latest videos from Ekeeda.
Hello friends, we have seen two questions. One is to prove that there is a membership algorithm for regular languages, and the second one was to prove that there is an algorithm to find out whether the regular language is empty or not. Now we will try to prove there is an algorithm which will find whether the given regular language is finite or not. We can say the problem is finding finiteness. Over here, we will be using the finite automata model for regular languages. We know that the particular finite automata has finite number of states. It cannot have infinite number of states, and hence any string which is accepted by the finite automata should have a traversal from the initial state to the final state. If there are infinite number of strings in the language, then the finite automata should accept infinite number of strings. Now, how is that possible? Because we need infinite number of paths in the given graph which has finite number of states. This is only possible if it is containing loops. Using this idea, we can design an algorithm to find out whether the given language which is regular is finite or not. The algorithm is quite simple. We have to construct an FSM, that is finite state machine, or a DFA, and we will try to find out if there is any loop between the path of initial state to final state. If there is any such loop which is there in between a path of final state, initial state to final state, we can argue that the given language is infinite. If there are no such paths, we can say that this particular language is finite. The next question is quite similar. It is exactly the opposite of the last question. Given a regular languages, we have to argue that it is infinite. Now, instead of finding there are no loops between initial to final, now we'll have to prove that there is a loop between initial to final. We will try to find out a loop from the path of initial state to final state. If we find such a loop, we can argue that infinite number of strings could be popped using that particular loop. As we discussed, this problem is of finding infiniteness of a regular language. The model we are going to use is finite state machine. The constraint is there should be a loop between the path from initial state to final state. Now the algorithm is as discussed. We will try to find the FSM for the given language, and we will try to find a loop at least in one path from initial to final. If we find at least one such loop, we can argue that the given language is infinite. Otherwise, the language is finite. In this question, we have used finite state automata as the model for representing regular languages. Instead of that, we may use a regular expression or regular grammar for proving the same. If we are using regular grammar, then we should have a recursion of the same symbol. Then we can prove that using recursion we can generate infinite number of strings. Similarly, in a regular expression, if we have a star closure, we can argue that using the closure we can pump some part of the string infinite number of times, and hence that particular language will contain infinite number of string, and hence the language is infinite. In the next video, we will be discussing about equality of two regular languages. Thank you for watching this video. Stay tuned to Ekeeda and do subscribe.